Okay, so here is the quiz that you just took. I hope you stopped and took the time actually to go back and look at it on Blackboard. That is really going to be helpful. I'm going to video it right here. We had 13 questions on the test. We're also going to have multiple choice open-ended, and there's one true and false question. It will also be a timed test, just like this quiz was timed. Please be cautious of that, but at the same time, before you submit that question, please make sure that you're confident in it. One thing that I've noticed so far from talking to the students is that there's quite a few students who were missing some of their homework, missing the DT-VT graphs because they didn't do it, didn't have all their notes completed. Again, having all of that stuff in front of you, and what did I say? Printed out. Not only that, but when you do it, when we're in class, that's when I go and I spend the time to really go back and give you the right answers. I try my best, and I know sometimes I get behind on trying to put the answer key up there, but I know that I go through the answers in class with us. So that's when you go and make your corrections, okay? So that way you have the right answers. So let's go ahead and look at this. There's a couple of problems with some missed questions that I know once you see it, you're never going to make that mistake again. First problem or first question was number 1. Many students missed number 1. But let me read it to you. How much time, okay, so already they start off with the question mark T, does it take for a race car that travels 200,000 decimeters while traveling 160 meters per second? Look at this. My units do not match up. Yes, this is a distance. Yes, that is a speed. But somebody needs to be converted. I would never ask you to convert 2 units. Could you? Absolutely, using dimensional analysis. But I'm not going to ask you. You've already did that with last year in chemistry class so much. What I am going to expect from you is be able to see this, catch it, and know that this is the one that you're going to have to do. So step 1, before you do anything, is that you need to King Henry this. Drinks utterly delicious chocolate milk. Decimeter is right here. It needs to go to, look at this, meter, which is over here, one place over to the left. So 1, 2, 3. The decimal is over here. Move it one place to the left. The new number is 20,000 meters. That is my new number, and that's what you've got to work with, okay? So now part 2 is speed equals d over t. I'm going to go ahead and triangle this to solve for t. So t equals d over s, or 20,000 over 160. That is how you're going to solve this. You're looking for the t, and your time is going to be in seconds, right? I think on the quizzes and tests, they're asking you to do not give us SI units. But go ahead and make sure that you read the question completely, because it's going to give you the directions in the question, okay? Let's keep going. While traveling along a highway east, a driver slows from 34 to 14. I'm going to pause for a moment. Obviously, I'm going to start talking about some type of acceleration. Why? Because it's telling me about 2 different velocities. It tells me that I'm going to slow from VI to 14. So I'm going to come over here, VI, VF. And what is the other thing? Before I move any further, they want to know the automobile's acceleration, question mark A, right? I know we talked about this in the notes. We've talked about it in the past. Let me say it again. I need us to start thinking physics-wise, and before we even come up with the answer, or even if they give us the A, B, C, D, we need to already know what our answer is going to kind of look like. And I know that I'm slowing down from this speed to a slower speed. What does acceleration's numbers look like if it's going to slow down? They're going to look negative. So if I'm looking for an acceleration, my answer better be a negative value. Okay, the time is in 60 seconds, t. If it was in minutes, we would have to convert, but the seconds are perfectly good. Okay, so A is my question mark. D was never given to me. T was 60. VI was 34, and VF was 14. If you wanted to use your flow chart, you would ask yourself, was D ever used? No. And in that case, the flow chart tells you, go ahead and use this equation, VF minus VI over T. And that is the equation we're going to use. Not only that, but we're going to leave the equation as is and solve for acceleration. So 14 take away 34 over 60 equals your answer. And it should be a negative answer too, okay? Let's keep going. Look at this DT graph. Well, let me go double check. How do I double check? Looking at the Y and the X. This is a DT graph. It says here, what is going on with the movement in this DT graph? Well, before I go further, I hope you did your homework and you did your paper. It looks like this. And this line that's sloped up like this, look at this slope, it matches that one. It means that my object's going to speed up. This line is away at constant speed. This line is at rest. This line is away at constant speed. Now, I like to go ahead, write down what's going on in my graph before I do anything. Now, let's go ahead and look at the answer choices now. Now, I know that the first part of it is speeding up. Let's look at this. I can cancel this part, this one, and this one. Now I went ahead and eliminated it down to just two. Speeding up, what is my next part? Away at a constant speed. Constant speed away. Then at rest, constant speed away. This is the correct answer choice right here. Next one, what is the object speed at 5 seconds? Using this graph. Now remember, I went ahead and wrote down what's going on already. And at T5, which is right here, let's go look up what's going on. It's at rest. How fast are you moving at rest? 0. That was a highly missed question. Next one. This part right here. Okay, so this was matching. You can get partial credit for it. They gave you units, and you had to match up what those units represented. So the first one, meters per second square, represents acceleration. Let's look at the next one, kilometers per hour. What does that mean? Speed. Why? Because there's no direction with it. What about miles per hour per second? Let me say it this way. Distance per time, or distance and 2 times. Distance with 2 times. This is acceleration. And then the last one, miles per hour. Does it have a direction? No. So that is speed also. That was a highly missed question. The next one. It says here that Susie rides her tricycle from point A to point B. Then she turns around and then she rides it from B to C. Now they also tell me from A to B is 22 meters. And from B to C, it's 7 meters. What is her distance? When I read the word distance, our brain needs to go to the word add. We need to add all of the distances that that object traveled. So 22 plus 7, 27, 28, 29, 29 meters. Okay, let's turn the page and keep going. Same information, same problem, except Well, what is her displacement? If this section is 22 meters and this section is 7 meters, displacement, or delta x or delta d, equals x sub f minus x sub I. Okay, so that means that we need to find the distance from here to here in a straight line. How far is that section? Well, if this whole line is 22 meters and this section right here is 7 meters of the 22, 22 take away 7, that is how far she went. Okay, 22 take away 7. So 13, 14, 15 meters to the left. Let's keep going. Now they gave us a VT graphs, and this is a DT graph. Which one matches? Which one of those VT matches the DT? If this was me, I would go and label. What does this downward slope means? It means a constant speed back to the origin. What does this line right here mean? At rest. And what does the third line means? Constant speed back to the origin. Now, using my VT graph, and now you see why we do the worksheets that we do, and we color code them, and why we do what we do, because everything that we do in this class has a purpose or meaning. So first thing is, which one of the graphs represents a constant speed back to the origin? Towards the origin at a constant speed. It better be below the x-axis, and it must be a flat horizontal line. Flat horizontal line below the x-axis. No. Maybe. No. Maybe. So now I'm down to a 50-50 shot. What is the next one? At rest. Which one means at rest? A flat horizontal line on the x-axis. Could it be this one? No. Could it be this one? That's my answer. Okay. Let's go ahead and let's keep going. A CHS student is running away from Principal Belcher after pouring slime on her truck, 28 meters per second through the parking lot. After 12 seconds, the student outran her and began to decelerate to -3.5 meters per second. How far did then the student run? How far did this student go? Question mark D. Alrighty. The student was running this velocity, and it took 12 seconds. And it starts to decelerate. Look at that negative acceleration of a -3.5. How far? So first step, A, D, T, V, I, V, F. -3.5, question mark, 12 seconds, 28 meters per second, VF was not given. Here's my information over here that I wrote down. If I'm going to use a flow chart, I would ask myself, was D ever discussed or used? Yes, it was. It's my unknown, so yes. Was T ever talked about? Yes, 12 seconds. Well, then your flow chart guides you to this. D equals VI times T plus 1/2 AT squared. What is my next step? I like my flow chart, but I'm not going to guarantee and put all my eggs in one basket. So let me double check it. D, question mark. Why? Because that's my unknown. VI, check. Do I have the T? Check. The 1/2, check. The A, check. The T squared, check. Not only did my flow chart guide me to the right direction, That is the equation I'm going to use, and I'm going to fill in the blanks and answer it as is. I do not need to rearrange anything. So 28 times 12 plus 0.5, I converted the 1/2 to a decimal, times negative 3.5 times 12 squared. That is my equation. Now my variables are all set in. Please multiply all those numbers and get your correct answer. The next question. This is a DT graph. Before I go further, let's label it DT. It's asking you what's going on and what is the best interpretation of this DT graph. Well, if you needed to, you can always go back over here. And a straight upward slope means a constant speed away. So constant speed away from the origin. The object is moving at a constant speed away from the start. That is the correct answer. Let's go ahead and look at the next graph. They gave us a VT graph. All of those are DTs. So now I'm going to go to my VT worksheet, and I'm going to go ahead and label what's going on. What happens when there's a flat line on the x-axis? It is at rest. Above the x-axis, it is away from the origin at a constant speed. Back to the x-axis, it is at rest. Okay? Well, let's go ahead and find, those are DT graphs. If it's at rest, does it have to be on the x-axis on the DT? No, it can be above, it can be below, but it has to be a flat horizontal line with no slope. That has a slope, can't be that. This has a slope, cannot be that one. This one starts off with a slope, cannot be that one. That is my only one. And I'm telling you, these worksheets are pretty darn nice. Have them in front of you when you're answering questions. Let's keep going. First step, what do? I'm going to always go ahead and label the type of graph I have. This is a VT graph. What is my next step? Well, I'm going to have my worksheet here in front of me, but I'm going to label what's going on. So this line means acceleration. This line means it's moving away at a constant speed. This line means acceleration. And this line means to slow down or to decelerate. Now that I'm going to feel more confident that I went ahead and labeled it, what's going on with this car during section A to B? It is moving away at a constant speed. What about between section C and D? Slowing down. What about from the start to section or point A? It is accelerating. What about from part B to part C? It is accelerating. And this was given to us as matching. We have another open-ended math problem. So let's go ahead and read this. I will take pictures also and post those pictures also of the quiz. A helicopter is at rest. Okay. Now, any object, remember, any object at rest, then it's going to have a value of 0. So the velocity is 0. Now, if it's at rest right now, then the VI is what we're talking about. Don't forget, in physics, words have number value. And take straight upward at an acceleration of 48 meters per second. A. And has a final velocity of VF 37. During this time of acceleration, what distance is this helicopter above the ground? Let's go ahead. A, D, T, VI, VF, 48. Question. X, 0. 37. Using the flow chart, was D ever discussed? Yes. Was T ever used? No. So now it tells me A equals VF squared minus VI squared over 2 times D. Remember, I like my flow chart, but I always want to double check it. Do I have the A? Check. Do I have a VF? Yes. Do I have a VI? Yes. Do I have a 2? Yes. Do I have the D? That's my question. Go ahead and either triangle this or go ahead and algebraically rearrange it. 48 equals 37 squared minus 0 squared over 2 times D. Subtracting 0 squared does nothing, so you can go ahead and X out the subtraction and the 0 squared. Now you can algebraically rearrange it and solve for the distance, okay? So again, it's practice, and it's practice over and over and over again. Let me stop real quick so I can take a picture and post this up for us so that way we can have this to look at, okay? Thank you.